So here we talk about a pool that has a rectangular base of 10 feet by 20 feet and a depth of 6 feet. And the question is, what is the change in your volume if you only fill it up to 5.5 feet? All right, so to answer this question, we know that our volume is equal to length times width times height. The problem, though, is we have too many unknowns. If we're going to talk about one variable, single variable calculus, we got to eliminate two of these unknowns. So you have to ask yourself, what is fixed? So in this problem, the length of 20, that is fixed because that's not going to change if I fill it up to 6 feet or 5.5 feet or 5.75 feet. It's still going to have a length of 20. And the same thing is true for the width of the pool. Again, doesn't matter how high I fill it up, it's still going to have a width of 10. So because those quantities in terms of filling up the pool are not changing, we can plug exactly those in. So we can plug in that length is 20, that width is 10, but the height or the depth of the pool is changing. And so that's going to be our independent variable. So we get volume is equal to 200 height, and then we're going to take the derivative with respect to that height variable. So what our differential will look like is dv is equal to v prime times the independent variable h, which is going to be our dh. Okay? All right, so if I look at dv here, taking the derivative of v, I get 200 because it's just linear in the h variable, and then times the dh. All right, so here what's happening is that we have a change, or a perturbation, I should say, in h of 0.5. Now, this goes back to that question of like, when is your h negative and when is it not? So it's supposed to be filled up to 6, but it's decreased. It's supposed to be at 6 feet, but it's decreased to 5.5 feet. So that would be when our perturbation in our input is negative. So we could, if we wanted to, we could represent the dh as a negative 0.5 because it's below the target here. Okay, and then that is times 200. So if you evaluate through that, you get 200 divided by 2, so you get negative 100. And again, this unit will be the same unit for volume, so it will be feet cubed, so cubic feet. And this is your change that is going to happen in volume if you only fill it up to 5.5 feet.